All right, today I want to go on to section 8.11, regular and irregular polygons. And in this section, we're going to learn just a couple new concepts, and then we're going to do an example of one of those kind of fun geometry problems. So, comparing and contrasting regular and irregular polygons. A regular polygon is going to be one that looks like this if I draw a regular pentagon. Now mine is not going to be perfect, but imagine that all of these sides are equal here. And my irregular pentagon can kind of look like this. 1, 2, 3, 4, 5. And none of these are equal. For us to have a regular pentagon, a regular polygon, we're going to need to define it as when all these sides and angles are congruent. An irregular polygon does not have any of those requirements. It only needs to have the number of sides in order to call it a polygon. So a regular polygon is going to have, if I even label it more, it could be something like an equilateral triangle is a regular polygon. Pretend all these are equal. And then all of these angles would also be equal. And anytime we can always kind of figure it out and kind of go up from there. If I need to figure out these angles, I can always just take my total number of angles and divide by the angles needed, and I should be able to figure out what I need. For example, I know that in a triangle, I have 180 degrees total, so I can just divide that by 3 to get 60 degrees. So I know that all of my angles here are 60 degrees. If I was going to do the same thing for a hexagon, I'm going to try to draw my hexagon okay. All my sides are going to be equal. And I know that, looking at my notes from the other day, hopefully I can find those quick. I can't, but if you look back, you can see that a hexagon has a total side of 720 degrees. So if I divide this by 6, because I have 6 angles now, let me pull that up on my calculator. I can do 720 divided by 6, and it's going to give me 120 degrees. So I know that each of my little angles here are going to be 120 degrees because they have to be equal in my regular polygon. All right, that's mainly the big difference between those two things. Let's take a quick look at a little diagram that we're going to do, and we're going to figure out some of these examples by using it. Let me draw it. We have a line here. We have a line here. And we have a line here. I'm going to label these sides. We have A, B, M, C, D, and E. Some angle measurements I know. I know that both of these are right angles. I know that this is 60 degrees. I know that this is 60 degrees. And I know that this is 120 degrees. And that's what I know. And the question that I want to try to figure out is I can notice some things about this shape. What I really want to know is I want to know the angles of C, my internal angle here, and my internal angle for B. And I can use a lot of the properties that I've been learning about to figure this out. For example, if I want this angle here, this huge angle, I know that, of course, is going to be equal to 180 degrees because it's a straight angle. And I can just use basic arithmetic to figure out the missing section of this internal angle of B. When I say when I say internal angle, I mean the angle that's inside of this shape. And this is a huge pentagon that I'm looking at, I believe. 1, 2, 3, 4, 5, exactly. So I want to know this section here. So to do that, I can do that pretty easily. I would just write 180 minus 60 equals angle B. And that's going to be 120 degrees equals angle B. So I can see that here I have 120 degrees again. Nice. This one is going to be, 90, of course, because it's a right angle. And this one is also 90. Now, for this last angle here, there's a couple ways that I can do this. But the way that we can do that now we know how to is this is a pentagon. So I can say that the sum of all of these angles is going to be, sorry, I forgot. Let me go back and look. This is what that chart is kind of handy that you can go back and look. In a pentagon, it's going to be 540. And I can say that's going to be equal to adding up all of the angles of all the sides. So I don't know this angle right here, so I'm going to put that one as x. But I do know all the others. I can say plus 90, plus 90, plus 120, plus 120. Oops, kind of went off the side there. And now it's pretty easy for me to solve for x. Let me grab my little calculator so we can do this and so you can see it. And I'm going to add up my whole side. I have 90. It's 90 plus 120 plus 120. That's going to give me x plus 420. Oops, I should have done it on the screen. Sorry. Equals 540. Okay, now minus 420 from both sides. Is equal to 120 equals x. And that's how I was able to find out my, I'm going to put a little arrow in there. I made this angle a little bit too small. Let's say I want this angle here, and it's going to be equal to 120 degrees. And we can kind of use that property in what we're talking about. The questions are going to be related to a lot of previous geometry topics that we've covered. So if you get stuck or if you have a question, ask a friend, look it up, or find an adult and ask for help. Good luck.